All right, we've talked about zeros of polynomial functions, so now we're going to take that one step further and talk about a test question that deals with finding all the zeros of the polynomial function. So the first thing we'll talk about is called the fundamental theorem of algebra. And basically what that's saying is that a polynomial has exactly every zero for the highest exponent. So if a polynomial is of degree 3, it has 3 zeros theoretically. Now some of them could be imaginary, you could have a repeated one. Obviously there's special cases, but those are the amount of zeros you should look for. The other thing we're going to talk about is the rational zeros test, and that determines all of the possible rational zeros. And then the other day we talked about how irrational zeros come in pairs. So we talked about if it's a square root, then there's also a negative square root. Same thing works with imaginary. So if you have a negative 4i and a positive 4i, they will go together. So if you have one, you have to also assume the other one. And we're going to come back to that a little bit more on day 2 of this lesson. But for now, we're going to focus on mostly the real ones. So the first thing you're going to do is, back before we had graphing calculators, you used to have to find what all the rational possible zeros were. And the way that we do that is by doing the rational zeros test. So you're given a polynomial and you find the factors of the constant term divided by the factors of the leading coefficient. And you're basically going to list all possible combinations. So first we would say P is the constant, and you would say P is 12. And notice I dropped the sign. You don't care about the sign. You're just taking the 12. Then you would say Q is your leading coefficient, which in this case is 1. Then you set up a fraction, and you have to have a plus or minus. So that's why I negated the negative up there. So I'm going to say plus or minus. On the top go my factors of the constant, and that was 12. So I would say 1, 2, 3, 4, 6, and 12. Then on the bottom, I would do factors of my leading coefficient, which is 1. Then you would match up all the possible combinations. Well, since in this one I just have a 1 on the bottom, all of them would just go over the number 1, and my possible zeros for this function are 1, 2, 3, 4, 6, negative 12, or 6 and 12, and it's all the positives and the negative ones. So it could be any of those. So if I were to graph this on a graphing calculator, it should cross at one of these 12 places. The reason I say 12 is because you have that plus or minus. So let's look at this one. So P in this case, the constant's 10, again, ignoring the negative. And Q, my coefficient is 4. So I'm going to do plus or minus. Factors of P go on top, so 1, 2, 5, and 10. Factors of Q go on the bottom, 1, 2, and 4. So this one's a little bit more complicated. So the way you're going to do this one, just develop some sort of system and then stick to it, otherwise it can get pretty confusing. So I'm going to take all the top numbers and I'm going to put them over the 1. Then I'm going to take all the top numbers, put them over the 2, and then all the top numbers, put them over the 4. So if they all go over the 1, that's 1, 2, 5, and 10. Now I'm going to take all of them and put them over the 2. So 1 over 2, 2 over 2. However, 2 over 2 reduces to 1, so I don't want to write it. You don't want to repeat any zeros. So 2 over 2, I don't write it because it reduces to 1. 5 over 2, I can write. 10 divided by 2 is 5, and I already have that, so I'm not going to write that one either. Now let's put them all over 4. So 1 over 4, 2 over 4, which is 1/2, but I already have that, 5 over 4, and then 10 over 4, which reduces to 5/2, and I already have that one too. So again, you're just listing all the possible zeros, and if I were to graph these, it should cross at one of these places or the negative version. Okay, so let's put that together with actually finding the zeros. So I want you to find all the rational zeros, and then we're going to graph it and see which ones it does actually cross at. So we'll do the first one here. So P, my constant, is 2, and Q is also 2. I'm going to do plus or minus. Factors of P would be 1 and 2. Factors of Q are also 1 and 2. So all my possible combinations there. Don't forget your plus or minus. So I would have 1 and 2 over the number 1. Then I have 1 and 2 over the number 2. 1 over 2 is 1/2, but 2 over 2 is 1, so I don't need it. So now I'm going to go to my graphing calculator, and we're going to type this in here. So 2x to the 3rd power minus 5x squared plus x plus 2. And then go to zoom 6 if you need to, just to set your standard 10 by 10 window. And there's my graph. So looking at where it crosses, these are all the possibilities, plus or minus 1, 2, and a half. So as I look at these, you can hit the trace button. And if you hit trace and then hit the number like 1 and hit enter, it jumps to the number 1. And you'll notice that it is in fact a 0. So I'm going to go ahead and write that down. It says write the function as a product of linear factors. So we'll say x equals 1 first. Looks like the other one might be 2, so I'm going to hit trace and hit 2. Excuse me, and it does cross at 2. And now the other one, let's say I think it's -1, so I hit trace -1. And when I hit enter, it goes to -6, not 0. So -1 is not one of my zeros. So that means it must be the -1/2. So I'm going to hit trace -1/2. And it is in fact the other one. So I'm going to go ahead and write that one here. So now it wants me to write them as a product of linear factors. So we're going to go ahead and do this. So remember, it's f of x. This is what we did back in, let's see, 3.2, I believe it was. So 1 and 2 are going to be the opposite, x minus 1, x minus 2. Now, when you do -1/2, you need to think backwards. So I'm solving basically one of these, and my answer is -1/2. The bottom number is what you would divide by at the end. So that means that's my coefficient of 2x. And then it was a -1/2. So I know that this has got to be a plus in order to make the minus go over. So some of these you just kind of have to play with and guess and then solve it and see if it worked. So if I set this equal to 0, would it give me -1/2? I would subtract 1, divide by 2. So yes, that does work. All right, so let's look at this one. So again, P equals 5, Q is 6, so set up my factors. So factors of 5 would be 1 and 5, factors of 6 are 1, 2, 3, and 6. So now that we have a graphing calculator, we can go straight to the calculator and find what the zeros are. But like I said, back in the day when we used to not have graphing calculators, you would have had to test all those possible zeros and see which one works. They still do, however, ask this test question just because it can be useful as we get to ones that perhaps maybe we can't graph as easily. So here's my graph. And this one's a little bit harder to see. I know that it is going to be one of these possible P over Qs. Let me go ahead and finish this one out. So plus or minus, I'm going to do 1 and 5 over 1. So that's 1 comma 5. I'm going to do 1 and 5 over 2. 1 and 5 over 3, and then 1 and 5 over 6. So I got lots of options here, and a lot of them are fractions. So going back to my calculator, I can look at this and say, pretty sure that that one over there is -5. So I'm going to hit trace -5. Yes, that is in fact -5. And then my other ones, I know that I should have 3 because it's cubic. So I know that in here, see how it's very small? I know that those are going to be very small numbers, but they're in the positive. So I'm just going to start typing these fractions in. So I'm going to hit trace and I'm going to hit 1/2. And that's a 0 because I got 0. So let's go ahead and write that one down. And then let's try another one. It's probably not 5/2, that's bigger than 1. We can try a 1/3. And that is my other one. If I had tried a 1/6, just so you can again see what one looks like when it's not, because my y value is not 0, 1/6 is not my true 0. My true 0 is 1/3. So I've got all those written down. Now I'm going to write it as a product of factors. So x minus 5, or excuse me, -5 becomes x plus 5. The 1/2, be careful with your coefficient. So I'm going to do it kind of fancy like I did up here, except this time it's going to be -1/2 or -1 because I would have to add that 1 over and then divide by 2. And the same thing with 1/3. That would be 3x minus 1 because I would add 1, divide by 3 to get the 1/3. So when we're doing these, you list out your possibilities and then you go to your calculator to confirm. So the next thing that we're going to do is a little bit of a different thing. So for this one, it doesn't explicitly say that I have to use a rational zeros test. So you don't have to write them all out for this one. What you're going to do, if they ask you to find all zeros, there's a couple steps you do, and this is a very classic test question because it tests a lot of things in one. The first step you do is you find zeros and I'm going to actually re-specify that. I'm going to say you find good zeros on your calculator. You want good ones. So I'm going to go to my calculator. I'm going to graph this function. So x to the third plus 2x squared plus 3x plus 6. This is a cubic, so I know I should have 3. I only see 1 though. And so when I look at that, it's x equals, so let's go look and see. I'm going to guess it's -2. So I hit trace, -2. Yep, that's what it is. So I have -2. That's the only 0 I see. So the other 2 are probably imaginary or they're off the chart somewhere. So what you're going to do in this situation, I know I have to get 3 more zeros, but I only know 1. You're going to do synthetic division with the one that you know. And by doing that, remember, every time you do synthetic division, you go down by a degree. By doing synthetic division once, my cubic will now become a quadratic, and then I could factor, I could solve it, I could do whatever I need. If I can get it to a quadratic, I know how to work that. So we're going to go ahead and do synthetic division with -2. Notice I didn't make it opposite because I'm using the true 0. I'm not using the factor. It's not x plus 2, x minus 2. So I'm going to take my coefficients. Don't forget to fill in a 0 if you have a gap. Add down, multiply around. Now, since I know this is a 0 because I found it on the calculator, you should get a 0 remainder. If you don't, then something went wrong. So here, because I know I found on the calculator, you should get 0. All right, so now I'm going to put my variables back in. So I went from a cubic to a quadratic. Don't have a linear, but I do have the 3. Step 3 then, you're going to solve quadratic. And then get your other 2. So if I'm solving this, x squared plus 3 equals 0, I would subtract 3. And then square root. So this is why I couldn't see them on the graph, because it was imaginary. You realize that the square root of a negative has an I, so it would be I root 3. So your answer, let's go back and read the directions. It says find the zeros and write the polynomial as a product of linear factors. So here's where vocab becomes key. My zeros are -2 from my calculator and plus or minus I root 3. My product of linear factors, which is how it's asking me to write my answer, would look like this. F of x equals x plus 2, x minus I root 3, and x plus I root 3. So key differences in vocab. If it's zeros, you just list them. If it's product of linear factors, you have to do the equation and you do the opposite sign. She could ask it either way on a test, so just watch for that. All right, so let's do another one. So your first step here then is to type in your calculator. So let's go ahead and graph it. I'm looking for 4 zeros possibly, in the end at least. So x to the 4th minus x to the 3rd plus 2x squared minus 4x minus 8. Okay, looks like I cross at -1 and 2, so let's check it. So I hit trace, -1, hit enter. Yep, that's at 0. Hit 2. Yep, okay, so those are my zeros. So from my calculator, I got x equals -1 and x equals 2. And if this is a test, she may want to see work for that. So the best way to show work is to just sketch it and just write it like that and just say like from your calculator. Like that's what she's looking for, is how did you get those answers? So that would be sufficient to prove how I got those 2. All right, so I started with a 4th power. I know 2 zeros for sure. So if I do synthetic division twice, I would get to a quadratic, because remember, you go down every time. I'm going to start with -1. It does not matter which one you start with. It'll look different along the way, but you should get the same final quadratic. So I'm going to go ahead and put my coefficients here. Don't forget, if you have a gap, to put a 0. Add down, multiply around. Don't rush this part too much. Remember, you have to end in a 0, and if you don't, something is wrong. All right, so I ended with a 0. Now I'm at a third power, but I need to do it again. So don't put your variables back in. You're going to do double back-to-back synthetic division. So I'm going to do it again with the number 2. Now, since I'm doing it again, I'm losing a column because remember, you went down by a degree. So add down, multiply around, and I got 0 this time. So just do back to back. So I've done synthetic twice, which takes me down 2 degrees. So I went from a fourth power to now I am at a second power. So it's x squared plus 4. Step 3 then is to solve this quadratic. So I will set it equal to 0. Subtract my 4 over. Square root that, which gives me square rooting a negative. So plus or minus. And then 4 is perfect, and then it's I because it's imaginary. Again, look at the directions. It wants it as a polynomial. So just to review, zeros, my answers would be -1, 2, plus or minus 2, I. Since they want it as a product of factors, that's where I write the equation with the opposites. So f of x equals x plus 1, x minus 2, x plus 2i, and x minus 2i. So again, all just depends on her wording for the question of what you want to do. I wouldn't recommend necessarily doing both always because then that kind of shows that you don't really understand the differences between the vocabulary. All right, we have one more. Third power, so I'm looking for 3 zeros, so let's go to our calculator. And type that in there. So x to the third plus 9x squared plus 27x plus 35. All right, so I know I need at least 1 to get me to a quadratic. Looks like I've got it. Looks like that's -5. All right, so step 1, I got -5 from my calculator. Again, if you want to just get in the habit of doing a quick sketch here. It's kind of a weird looking one, but as long as you've got that 0 to prove it. I'm going to do synthetic division just once this time. That's all I need to get to a quadratic. Add down, multiply around. I started with a cubic. I did synthetic once, so that puts me at a quadratic. Step 3, I'm going to solve that. So when I look at this, I notice it doesn't factor, and I can't use square roots like I have in the last 2 examples. So my solution for solving a quadratic then is to do quadratic formula. So opposite of b, plus or minus b squared minus 4ac all over 2 times a. So I've got -4 plus or minus, and when I do the inside, I notice I'm going to get 16 minus 28. So I'm going to actually get a negative number underneath. So that's why I couldn't see these ones on the graph because they are imaginary, and I found that by the quadratic formula. You can still simplify the 12. I could take the 4 out, which would become a 2, and I'm also going to take the I out. So I get 2i root 3 divided by 2. Last step here, you can take a 2 out of all 3 of these. So this would become 2, 1, and 1. So then my answer would be -2 plus or minus I root 3. And I don't really need to put it over the 1. So that would be your answer. Again, look at directions. It says write it as a product. So if you were doing zeros, that would be the one I got from up above, which was -5. And then these guys over here. Now, this one's a little bit harder to write as a product. And this honestly sometimes, excuse me, is a test question all on its own, is writing a product of linear factors when it looks like this, because this one's kind of tricky. So when I look at my zeros and I'm writing my answers here, I know it's f of x, and I know it's x plus 5. What's tricky is the -2 is obviously going to be x plus 2. But then you have the plus or minus that bounces back and forth in front of the radical. So here's where you have to be careful. So my first scenario is plus 2 plus I root 3. So that's the first one. Then when I do the second one, here's the mistake people make. The plus or minus is not on the 2, so the 2 needs to stay the same as it is here. So it's still going to be x plus 2, but then it's minus I root 3. So the plus stays with the 2 for both, but the I is opposite. So just be very careful with that. That's a trick that they often like to just try to test you on, again, just as a separate test question, even with that the constant stays the same, but the I is the one that bounces back and forth. Okay, so that's your full system, finding all zeros. That's your direction. It's kind of scary on a test when that's literally all they say is find all the zeros. Sometimes you blank out with what to do. But this is your step: calculator, synthetic, and then quadratic formula or factoring if that works.